All right, this is lesson 6.1. This is the second video, and we want to do more of these inverse trig functions. And as we do these, I just got to remind you of one little thing as we're taking the inverses. Whenever we do an inverse, or whenever we take anything, we would like it to be a function. And what a function is, when you put in a value, so it takes in a value, and it gives you a unique answer. And I don't know if you remember back in Algebra 2 or even in Algebra, to tell if something was a function or not, you would use the vertical line test. If I drew a graph like this, you'd say, oh, that passes a vertical line test, because any vertical line only passes through one point. If you had something else, some kind of a graph that was a parabola tipped over or something like that, you'd say, no, that flunks the vertical line test, because I can draw vertical lines. They can hit more than one point. Well, this issue is going to come up with our inverse trig functions. And let me just show you in the unit circle why this comes up. And then we'll practice a bit with it. And it will come up because if I asked you, and we didn't deal with it much in the first video, but we could have. If I asked you, what's the sine inverse of a half, you happily looked here and said, oh, look, it's 30 degrees or pi 6. But you could have looked over here also. The sine is a half over here also. You could have given me in this, oh, there's a typo all over this sheet. Oh, no, this is horrible. You'll have to fix those. I'll have to print out new copies for people with the corrected versions on there. But that was really 150 degrees right here. You could have said 5 pi 6 or 150 degrees for the sine inverse of a half. And the agreement was, when they're positive answers, give me the first quadrant answer, and there's no problems. And so when you put in one value, give me one answer. You can't give me two answers. I don't want 30 degrees or 150 degrees. That's not a function. I want one answer. Okay, so this comes up more clearly, because it's kind of natural to give first quadrant answers. This comes up more clearly when we're dealing with the negative trig functions, or the inverses of the negative ones. So we have to be careful when you give the answer that we give one answer, and everybody agrees on what that one answer is going to be. So you take the inverse trig function of a positive value, we gave the first quadrant answer. No big deal. However, when we take the inverse of a negative value, it's not quite as easy, because there's not one quadrant where all 6 trig functions are negative. Remember A-Smart trig class? There's always some quadrant where something's positive. And so it made sense when things are positive, gives the first quadrant answer, because they're all positive in the first quadrant. But when they're negative, the agreement is this. If I'm looking for a cosine inverse or a secant inverse, if it's positive, look in the first quadrant. If it's negative, give me the second quadrant answer. And we also agree on the cotangent inverse. If it's negative, give me the second quadrant answer. Okay, that won't work for sines. So if I want the sine inverse or the cosecant inverse, first, if it's positive, give me the first quadrant answer. But if it's negative, give me the fourth quadrant answer. And we have that same agreement for tangent. And so this was just an agreement made by mathematicians all over the world. So when people are doing inverse trig functions, you get the same answer. Everybody around the world gets the same answer. And we're not arguing, should I look in the second quadrant or the third quadrant, or the third quadrant or the fourth quadrant? No, it's already predetermined. When you're looking for the inverses of positives, easy, look in the first quadrant. But if you're looking for the negatives, if it's cosine, secant, cotangent, look in the second quadrant. When it's sine, cosecant, tangent, look in the fourth quadrant. All right, so let's practice this a few times. What's the cosine inverse of negative 1/2? So go back to your unit circle now, and again, I will print you out a copy with the correct degrees on here too. Cosine, negative 1/2, cosine is the x-coordinate. The agreement for cosine is look in the second quadrant. It's right here, it's 2 pi thirds, and you know that's not 30 degrees. You can convert that. That's 120 degrees. So cosine inverse of 1/2 would be 120 degrees, or 2 pi thirds. Sine inverse of 1/2, then the agreement is look in the fourth quadrant. So let's look. Where's the y-coordinate? Negative 1/2. Let's look down here. Looking for the y-coordinates right there. Y-coordinates negative 1/2. and those radian measures are correct, the degrees are not. It's 11 pi 6 or 330 degrees. So I can go 11 pi 6 or 330 degrees. There's another thing we do when it's in the fourth quadrant, which actually makes your life easier. We just say, wait a minute, I could go around this way, you know, counterclockwise 330 degrees, or couldn't I just back up and go this way? And if I'm backing up, that's a negative angle. So I could just back up 30 degrees. So when there's a negative for a sine, or a cosecant, or a tangent, what we can also do is say, so it's 11 pi 6 or 330, or even more common, we can say, look, just back up 30 degrees. It's negative 30, or in radians, it'd be negative pi 6. So it makes it easier for the sine inverse and the tangent inverse and the cosecant inverse just to say, look, it's in the fourth quadrant. How do you get to the fourth quadrant? Well, the quick way is just go backwards. So negative 30 degrees or negative pi 6. Tangent inverse of negative 1, same thing. Look in the fourth quadrant. How much do you have to back up? Well, look and see. You go back 45 degrees or backwards pi 4ths. And the cosecant, oh shoot, cosecant is reciprocal of sine. I've got a negative. You don't leave roots on the bottom. There's this one student first hour who's an expert and he square roots on the bottom. And I've got the sine inverse of negative square root of 2 over 2. Where's the sine? Square root of 2 over 2, 45 degrees. But we're going backwards. So I'll say back up 45 degrees. Or back up, whoops, that's going to be pi 4ths, but make sure there's a negative in front of it. And those would be your answers. So it works nicely for sines, tangents, cosecants. Not so nicely for cosines, because cosine's positive in the fourth quadrant. So the cosines, you've got to look over there and see what those values are. 120 degrees or 2 pi 3rds. All right. Those are the main ideas. There's one last little idea where they mix these up a little bit. And I'm going to show you one here, and then that will be enough. And then if you don't get it, it'll be a third video that explains more of these in detail. So a question could be, what's the sine of the arc cosine of 1/4 or something like that? You can combine all these trig functions and all sorts of combinations, and here's another and another and another. And there are 4 problems, but they're all really the same. Okay, when they give you a problem like this and they say solve this without your calculator, you begin with that arc cosine, and you know arc cosine is the same thing as the cosine inverse of 1/4. You might look at it on your chart and realize I don't have that on my chart. So what's the cosine inverse of 1/4? I don't know. I do know it's going to give me some angle for an answer. So I'm just going to call it theta for right now. Then, algebraically, I would like to solve, or I'd like to get this 1/4 by itself. How do you get rid of a cosine inverse? And the answer is, oops, apply the cosine to both sides. And guys, the cosine of the cosine inverse cancels out, and I get 1/4 equals the cosine of theta. So I take this idea, and again, if you don't get this the first time, there'll be another video that shows this a couple more times. I'll sketch a right triangle. I'll remember SOHCAHTOA. Cosine is, this is my theta. Cosine is the adjacent over the hypotenuse. Pythagorean theorem, I'll figure out the other side. I've got 1 squared plus x squared equals 4 squared. Looks like x is going to equal the square root of 15. I've got that over here, and then I'm about done. Because I come back here and say, look, I was looking for the sine of this cosine inverse, but guys, I had said the cosine inverse is just theta. So I'm really looking for the sine of theta. Wait, SOHCAHTOA, sine is opposite over hypotenuse. Done. All right, actually, let's do one more, and I'll save the other 2 for the next video. Try it again. What's the cosine of the tangent inverse? Begin with that tangent inverse and say, I don't know what the tangent inverse of 2 is, but I know it's going to give me an angle. I'll call that angle theta. How do I get rid of the tangent inverse? I'll take the tangent of both sides. I got the tangent of the tangent inverse. So I've got the tangent of theta. Oh, look at that. How nice is that? Tangent inverse cancel out. So the tangent of theta equals 2. Sketch my triangle. Here's my theta. SOHCAHTOA. Tangent is opposite over adjacent. Pythagorean theorem. 2 squared plus 1 squared equals your hypotenuse squared. So 5 is your hypotenuse, so root 5. So I'm sorry, square root is your hypotenuse squared was 5. So root 5 is your hypotenuse. Come back here. Wait, what was the question? It was the cosine. I called that theta. What's the cosine of theta? It's adjacent over hypotenuse. Don't leave square roots on the bottom. And I end up with root 5 over 5. All right, there's 2 more of these. I'll put it on a 3rd video. But I think by now, hopefully you have the idea. If not, we'll practice this part more in class. So this takes care of pretty much the first section.